intelligence company that specialises in the analysis of feedback. We incubated out Falmouth University about 10-ish years ago now at this point, and we've been working down in Cornwall ever since. We work in a number of sectors: games industry, health, and other entertainment industries. Anywhere, if you think about anywhere where a lot of feedback is left, we've probably touched on it at some point. We were named one of the top 5 AI companies and projects by the UK government in a relatively recent report that was put out. Myself, I'm the CIO and I'm a co-founder of the business. So back when it was incubating, I was there from the very start. I've been building and running the business for about 10 years now. And I'm responsible for all technical direction and decision making within the business. So when we sit down and we decide, when we look at what are we going to be doing going forward with our tech, where can we use it internally and externally, the buck stops with me, basically. On that note, so what we're going to be covering today, in the first part, I'm going to talk about trying to define artificial intelligence for you guys. It's a very expansive field, but I'm going to talk about the stuff that I know well and some very general terms to kind of get you settled. And then we're going to talk about some use cases where AI is applied in various businesses to help to kind of contextualize that understanding. And then we're going to talk about how you can start your AI journey. So many of you are working in business or running a business yourself, and so when you go back to your businesses, how can you look for opportunities where AI would be a crucial and important advancement in your business? So part 1, artificial intelligence defined. So firstly, I kind of wanted to talk about some misconceptions with AI. Before we can talk about what AI is, we need to kind of define what AI isn't. There's 2 generally broad concepts here: artificial general intelligence and artificial narrow intelligence. Okay, that will this one. So the idea of an AGI is that it's all singing, all dancing. It's basically a person that has been built. So that is your HAL 9000s, your Terminators, your, the film AI, that kind of stuff. That does not exist. That is a Hollywood invention. What we're looking at today is artificial narrow intelligences, and sometimes called weak AIs. They are specialist pieces of software trained and designed to do a task in a different way from what you would imagine a normal piece of software to be developed, in the sense that what you do is you feed them quantities of data and they learn how to respond based on that data. So in that case, a lot of that comes under the branch of machine learning. There are other branches of AI, things based around, but generally everything is based around something called a neural network, which is a software that is designed to kind of replicate some functionality of the human brain in a very kind of overview capacity. So machine learning, the process by which we feed lots of data into a piece of software, and from that we get desired outputs. So there's 2 broad classes of that, and you kind of get a bit more of an understanding of what I mean by that in a second. We have supervised and unsupervised learning as those 2 broad classes there. Supervised learning. That's defined by the fact that the data that you feed to this machine learning in supervised learning has been already given the answer to the problem you're trying to solve. So, for instance, there's two kind of main jobs that you can use this for: classification and regression. Classification, a good example would be being able to tell if an email is spam or not. Would be an example of a classification problem. And so a labeled data set in that problem would already have emails that have been defined as spam or not. So you can learn so the system can learn from that and then take that learning and then apply it to new situations it hasn't seen before. Regression, on the other hand, is all about predicting values. So how does the weather predict ice cream sales would be an example of that. A pretty basic regression you can look at. what you do is you take as much data as you can about weather patterns and things like that, and you measure that against your ice cream sales, you feed that into machine learning, and machine learning then knows, okay, well when these weather patterns occur, I can predict ice cream sales will be kind of like this, like low or high, depending on what the weather's like. On the other hand, unsupervised learning is all about not needing to do that kind of process to the data beforehand. So the ML solution in that case can look at some sets of data and do something with it without having to necessarily sit there and label everything. There's two broad types of algorithms that exist in that space, which are very useful. Clustering and association, which you would think sound like the same thing, but are actually applied differently. So clustering is all about grouping things that are similar together, whereas association is about grouping things that aren't necessarily similar but related. So clustering is all about, okay, these patients have had similar outcomes, we need to group them together, we can understand why they've had similar outcomes based on various data points. Whereas association would be, I bought a bike recently, this shop recommending that this sort of like customers who bought this item also bought bike pumps. Bike pumps aren't bikes, but they are related. You can see the association there, and that's what that's all about. So kind of from looking at that, we've kind of gone over the two types of ANIs that we look at machine learning. We looked at this AGIs and ANIs. AGIs aren't real. We're going to be focusing on ANIs. So how are ANIs used, and machine learning specifically, in businesses? So yeah, so that was the slide I just talked about. So use case one, Facebook. Everyone's used Facebook, or well, I imagine everyone in here has used Facebook. One of the biggest social media platforms in the world. How do they detect illegal material submitted to the platform? So you have users uploading tons of content every day, right? Absolute terabytes, petabytes even, of content every day. You can't filter all that with a human detection, like a human filtering team or something like that. Content moderation. It becomes untenable. So how do you do that? Well, you train systems to say, okay, is this content illegal in some capacity? And you have various different systems, so for various different criteria, you have to train different classifications for them. So for instance, is this content radicalizing in some way? Train a system to detect that. Is this content like graphic in some way? You have to train a system to detect that. And so Facebook kind of lead the way in a lot of this stuff because they have a lot of data, a lot of stuff they need to do this for. They're very far with that. Use case two, we're kind of getting into stuff that we at Hertzian do more, predicting sales performance. So we actually had a client in the games industry. They were specifically within sales. So what they did was they talked to various publishers, that kind of thing, and they would put on sales on various digital storefronts. What we built from them was a machine learning model that looked at the past performance of sales that they had across all of their products and estimated what the performance of their new proposed sales would be, and also look at, okay, would we make more money if we offered something at 20% or 10%? So, because obviously if you offer a thing at 10%, you make less money per sale, but you might make more sales overall. And so it's all about predicting the total number of sales at each value and then evaluating that. That itself was a form of regression. So you can see that's how regression ties in. Use case three, analysing NHS survey feedback. So we actually work with the NHS, the NHS EI and Pickering Institute on analysing various surveys for them. So you have your friends and family test and your national staff survey, that kind of thing. One of the things we do for them is actually a form of unsupervised learning in where we take their data and we categorise every response into the things that they're talking about. So they might be talking about the bed situation in a particular ward, or they might be talking about how the nurses are understaffed or something like that. And what we do is we aggregate all of those reviews together, or survey responses together, and people can analyse them and have another look and do various other things with them. And that's a form of clustering, so you can see where clustering might be used there. So understanding, okay, so there's stuff that, so you understand there's AGIs and ANIs, and ANIs are what we use. And here's where we might use some ANIs. How about you? How do you want to use AI in your business? So we're kind of going to run through a quick example here. So Bob runs a service company here in Cornwall. Sounds familiar to some of you in here, I imagine. Bob's company sells software services to other companies. How can AI help Bob's business? So you would think that, okay, you could sell AI to other businesses, but that's not the only way. But there is a few points to consider first. AI is a tool. It's not applicable to every problem. There's a lot of problems out there that can be solved with traditional software methods, and an AI solution is over-engineering. And you don't want to go down that rabbit hole if there's a very simple solution out there already. So what you want to look at AI for is for problems that normally require a person, that you feel like you can't automate. And AI is where the solution and the path forward might be. Producing quality results is a specialist role as well. So what that means is you can get started in your AI journey and you can start working with data, but at some point you might hit a wall and you might need to talk to someone who's a specialist in that role. And then the results aren't guaranteed. When you work, the performance of AI is very much tied to the quality of data and how well it represents and builds a picture of the thing that you want to examine. So in that sense, you could be building an incomplete picture that won't perform as you'd like. And so these are things to always consider. So the first thing you want to do is you want to identify your AI use case. So what problems do you have? So you could have customer retention issues, or you could have numerous other issues. In Bob's case, he's got a support ticket. He's got a support ticket resolving issue. He can't resolve his support ticket quick enough, and they're not organised correctly. They're not organised in such a way that he feels that he's losing clients because of it. Say. So obviously on that, his KPI management would be the speed to resolution and the correct classification of support tickets. So does he see the urgent issues first, or does some of them get lost? Things like that. You need to identify the internal and external stakeholders. So in this case, Bob's stakeholder is an external stakeholder. It's the person with the problem. So you're looking at, okay, I want to help the people that come to me with issues around the software I provide. I need to solve it quicker. I need to more quickly categorize their issues. And it's the automation of an existing task. So that means that I should have data somewhere that can help me with this. Because when you're trying to do a new offering, you have to think about where you're going to get your data from to build your solution. But in this case, he's been doing support tickets for potentially years at this point. He should have a set of data available to him that he can look back on and go, okay, I can take this forward. And so do you have a data set? Yes. All the past tickets I've resolved. So now you need to define your outputs. What do you want from your AI? Okay, so I want my AI to read a problem automatically and say it needs to be an urgent ticket, it needs to be a not urgent ticket, so that as these support tickets come flooding in, I can prioritise the highest performance, the most significant ones first. So that would be some kind of rating, a label, so to speak. So from there, you know you have a classification problem. You need to classify your support tickets. So now you know, okay, I've got to classify my support tickets. Where do I go from here? Well, first of all, you check if something already exists, because you don't want to reinvent the wheel, right? as far as I'm aware, nothing exists for that particular issue, but there's general software tools where you can go in and classify, and I imagine there might be something out there, but there's nothing I'm aware of. Do you have the base technical foundation? So if you don't have technical experience, this is the point where you might have to start engaging with someone like a specialist or something like that. However, if you have in-house technical capabilities, you can start to progress that a bit further. You might want to start looking and playing around with high-level libraries and languages and start feeding your data into them. So I would recommend Python, and you can look at various libraries in there such as PyTorch and Keras. It's, I think, the best supported language for any kind of ML you want to do, or AI. Yeah. So just to summarise, we went over what the general things in AI are in terms of ANIs, AGIs, supervised and unsupervised learning. We kind of saw where those things were applied and like how you could get started on your AI journey, which I'm sure a lot of the coming talks will also help you with kind of in a bit more detail. Thank you for listening to me. I've got several colleagues with me today, Chris, David and Luana. They're just over there, so if you want to talk with myself or them, they're really freely available. And so follow us on social media, and we're also recruiting. So if you're interested, we are actually looking for a web developer at the moment. So let us know careers at Hertzian. Thank you for your time, and I hope you have a good day.
Big thank you to Andy and the Hertzian team there. Hopefully that kind of unfogged the AI myths that any of you may had. And we've got a really interesting complimentary talk at the very end of this, the agenda with Tanya, who's here today, who's also then going to dispel some of the myths of AI and challenge some of our assumptions on it. So yeah, thanks again so much, Andy. Next up.